Hello, everyone. My name is Aditya Mishra, and I'm the Digikey ambassador for UCLA. And today I'm going to talk to you guys about how to create multicolored 3D prints using a standard 3D printer. What I mean by that, this is the type of 3D printer that can be found in pretty much any makerspace across the country and can even be bought for home use. You don't need to buy any super high-tech, super specialized 3D printer to do what we're going to be talking about today. And what I personally think is more exciting is that all of the procedures I'm going to be talking about in this video can be done with entirely free, entirely open source, and primarily super lightweight software, meaning that this can be done by anyone, regardless of whatever type of computer you have, regardless of whatever your access is to like expensive software like SolidWorks or even something like Photoshop. This is all done super free, super lightweight, a really great way to get started with making stuff. So first, we're going to talk about why creating multicolored 3D prints for cheap is important. And then I'm going to go through and talk about the different type of software and websites that we're going to be using for this process. After that, we're going to talk about the type of design that this process works particularly well for. And then we're actually going to go into the nitty gritty of actually editing the design, converting it to an STL. An STL is just a file type that is used for 3D printing. And then we're going to do something that's really interesting, which is designing in a software called Prusa Slicer. So for those of you who might be more familiar with 3D printing, you might recognize Prusa Slicer as a slicer, which is typically just a software that's used for converting an STL, which is one type of 3D file, to a G-code file, which is a type of file that a 3D printer would understand. But something that most people are not aware of is that you can actually do some pretty easy designing in Prusa Slicer itself. It's a great software for creating your own STLs, and I think that people are not aware of this process, something I wanted to highlight today while I went through this video. And finally, I wanted to show you some of the projects that I have created using this method. And I just want to thank you all for taking the time to look at this video. So first things first, let's talk about why this project actually matters. And the very common sense answer to this is that being a maker is unfortunately super expensive. There's a really high barrier for entry for being creative and making cool stuff. If you take a look at the right here, you can see that the two most common ways to do multicolor 3D printers are by one, either buying a dedicated 3D printer that can have 4 spools of filament attached to it. The one shown here happens to be a Bamboo Lab X1 carbon combo. This is probably the one that's used the most if you want to do multicolor 3D prints, and it runs you about $1,500. And the other option right here is the Mosaic Palette 3 Pro. This is not even a 3D printer. This is an $800 device that's used to actually create like a spool of filament that is going to be then extruded from another 3D printer that you have to buy separately uh, to create a multicolored 3D print. Both of these options are really cost effective, or they required some really specialized software, or they required some really specialized hardware, all of which can start running you up a lot of money. And as you can take a look down below, like there are already cost-effective alternatives for 3D printing. One of them that you can see on the left is probably the most standard entry-level 3D printer that you can get, which is the Ender 3. The Ender 3 is less than 200 bucks, but the one that we're going to be focusing on today is the Prusa MK3S Plus. That's about an $800 printer, but it can be found at most maker spaces across the country, and it's very accessible for the average person to use one of these Prusa printers. Maybe not average person, but if you're like a college student and happen to be in an environment where 3D printing might be more common, the Prusa is probably the most common printer that you'll have access to. And as you can see, even these devices, which are more of like the entry level devices, can be extremely expensive. And this is just talking about hardware right now. We're not even talking about the filament itself. As you can see, each of these spools of filament is $20+. And if you look at this diagram right here, this is an example of a multi-material or multicolor print. You can see the sheer amount of waste that's happening right here. Like the amount of filament that's going that you can see in this purge bucket right here is probably close to like $1 or something like that. Now, $1 might not be a much, but when you start doing a bunch of multicolored 3D prints, that's going to add up really, really quickly. Now, moreover, we've only talked about like the hardware and the raw material needed to actually do the 3D printing itself. Something that a lot of people don't take into consideration is the fact the software is super expensive as well. The standard 3D software that's used by most engineers is SolidWorks, and unfortunately, a SolidWorks license will cost about $2,700 a year. Uh, this is really not accessible to a maker or a hobbyist who just wants to create some cool 3D prints. And additionally, if you want to do some video or photo editing, you'd have to get software like Photoshop, which can cost you up to $270 a year. That's really not very accessible for someone who wants to be just making something for fun, you know? And moreover, both of the softwares that I just described, SolidWorks and Photoshop, are not lightweight at all. What that means is that they are going to use a lot of system resources. You're going to need a computer with a lot of RAM. You're going to need a computer with a lot of storage. You're going to need a computer with a really good CPU and maybe even a GPU for something like SolidWorks, to be honest. And the entry level price for a laptop like that, or even like a desktop, is going to be about $1,400. That's way too much to just get started to make some cool things, in my opinion. I think that people ought to have a really low barrier of entry to be creating what they want to create. And I think that brings me to the required software and websites that you're going to be using to have a lightweight, low cost, but still really quality experience of making multicolored 3D prints. And the first software that we're going to be focusing on is Inkscape. So Inkscape is a free and open source vector graphics editor. So you can sort of think of it as Photoshop, but for free. And what we're going to use that for is to take our initial PNG design that someone else created and turn it into an SVG file. From there, we're going to modify the SVG file and throw it into Tinkercad. So Tinkercad is a 3D design software, but what we're going to do is we're going to use its capability to convert 2D images to 3D images really easily. And that will allow someone who doesn't really have a high level experience with CADing, with computer aided design, to actually do this 3D design in a sort of 2D fashion. That'll make more sense once I show it to you. So for this, we're going to take our 2D design, our SVG, and convert it to an STL, which is the type of file that's used for 3D printing. And finally, what we're going to do is we're going to take all of our different STLs together, put it into Prusa Slicer, design within Prusa Slicer itself, which again is a function as a feature of Prusa Slicer that most people aren't aware of, and then convert it to a G code and get it all printed up and ready to go. So this is going to be the high level process and the high level introduction to the software that we're going to be using for this project. Now, I want to take the time to actually go into more depth regarding each of these softwares because I really do believe in the mission of each of these products. The primary mission of all these products is that they are free and or open source. So for Inkscape, something that's really, really used by a lot of people in the hobbyist space is something that is free and open source. So there's no barrier of entry like Photoshop or really a bunch of other softwares out there to do some vector graphics editing. Vector graphics is important because like if you take a look at the picture of the Twitter logo on the right, the one on the left is a vector image. As you can see, it's not very blurry at all. And the one on the right is a bitmap or a PNG or JPEG, whatever file type it could be, which is just a bitmap. And as you can see at the edges, it gets really, really blurry. Getting a vector graphics editing software can be really expensive, but Inkscape does this entirely for free. Additionally, something that's really cool about Inkscape is that it works on any computer that you have. So you can get any system in the world and Inkscape should work on it. And it has a bunch of different drawing tools. It has a lot of like an open source collaboration platform, which is really interesting. And it has a lot of accessible tools that can be used for education. And it really is just the pinnacle of open source software in the graphics space. So that's something that I really feel like is important to highlight for this video. Additionally, another software that we're going to be using is Tinkercad. So Tinkercad, as I mentioned previously, is another free online 3D design tool. So you can use this for designing really complicated 3D shapes. For today, we're only going to use the most basic functionality of it, which is to take a 2D image or a 2D SVG and convert it to some 3D image that we can use for later design. This is probably the most beginner-friendly 3D designing tool that you can have. And what's really, really awesome about Tinkercad is it's done almost, I think, entirely over the cloud. So none of the computation is happening on your own system, which means that you could have, as long as you have a computer with an internet connection, you can do as much 3D design as you want. You can do physics simulations as well, which is actually what this bottom right image is showing. And typically, image simulation with a CAD software, you would have to get something like SolidWorks, which would be really, really expensive, as I mentioned earlier. And finally, the other software that we're going to be focusing on is Prusa Slicer. Prusa Slicer is an open source 3D printing slicer, which is a huge deal because of the fact that a lot of people have put in their time and effort to create this slicer that is used by, I would imagine, thousands, if not hundreds of thousands of people across the planet. And this is probably beginner-friendly, the most beginner-friendly the slicing and or design software that I think I've ever used. Most people are not aware of the fact that you can actually do some really rudimentary design in Prusa Slicer, and that's something I just want to shed light on. Even if you don't have a Prusa printer, you can use Prusa Slicer itself to do some pretty rudimentary design. And that's what this video and the corresponding blog post is going to be about. So now that we've talked about all the different components that we need to actually do our design flow, let's actually talk about the first step of our design process itself, which is going to be just picking the design. Now, this is something that I've tried to do with a lot of different images, and unfortunately, I found that the simpler the images, the better. As you take a look at the image on the right, on the left, this is an image of Powell Cat, which is the UCLA campus cat, which unfortunately passed away last year. And this was a design by Lindsay Montgomery to commemorate the cat on a t-shirt. If you take a look, you can see that there's not too many colors here. There's really only three different colors: black, white, black, blue, and yellow. And it's all really simple. They're all closed shapes. There's nothing like any crazy shading is going on or anything like that. It's not super photorealistic. This is the type of design that will work best for converting a PNG to a STL. Now, if you take a look at the right, this is a image that I previously tried to convert to an STL, and that process did not work at all. You might think it's because of like the shading that's going on with the clouds right here, but no. What was really interesting is that even these like light gray brown colors right here, when you tried to collapse those in Inkscape, there was causing a lot of problems for me. So you have to just make sure that the image that you're choosing is fairly simplistic and has few colors and is closed shapes. So I would recommend getting started with like a cartoonish image at first for sure. So somehow we need to take this PNG that you see on the left and convert it to some G code that a 3D printer will understand on the right. Like that's a really involved process. How the heck are we going to get from A all the way to D? So I can quickly give a high level flow. We're first going to take that PNG and convert to an SVG, then move it to an STL. So that's the conversion from a 2D object to a 3D object. And then you're going to have to combine and merge a bunch of these 3D objects together to make one big 3D object that we can use for a commemorative plaque for Powell Cat. But first, before we go through this entire detailed process, let's just focus on the conversion from PNG to SVG first. So the way that we're going to do this is by using Inkscape. What we're first do is you literally just import the PNG. So that means like Control C and Control V it in, or if you have it located on your file system, you just import the PNG. And then you're going to select the image and click Path Trace Bitmap, which is the keystrokes that I'm showing you right here. You select the path window on the top, you'll see an option for tracing bitmap, and then that will give you something that looks something like this. So you will open a window that is the window that's used for tracing bitmap, so it's titled with trace bitmap. And this will allow you to convert your PNG to an SVG, which is a super, super powerful feature. If you remember previously, I showed you the image of the Twitter logo, and there was one that when you zoomed in, it was super blurry around the edges, and the other one that was super clear. That's because the one that was super clear was an SVG. This is something that we want to do. We want to make sure we have really clear edges. So the way that we're gonna convert our bitmap to an SVG, our PNG to an SVG, is by using the most simple feature, which is the brightness cutoff, which is going to give you like a general trace of our Powell cat. And if you take a look, whenever you select this brightness cutoff field, there's a brightness threshold window right here. You can just change the brightness threshold, adjust it a little bit, and take a look at see what happens to the preview in this window right here. And once your preview is to an image of your liking, just select apply and you'll be given a SVG on top of your original bitmap that you can use for your future design. Now, an issue that you're going to run into is that the SVG that we're going to have is still going to have a bunch of open areas, which are like holes that are not going to 3D print easily. Now, the way that we're going to fix this is that we're just going to edit the nodes. So really quickly, what do I mean by that? So if you see here, this paw that's on Powell Cat, is like a very open shape. It's not something that's going to 3D print very easily. Like 3D prints, you're literally like putting plastic over plastic, right? The thinner that is, the weaker it's going to be. We need to make sure that's stronger, so we need to delete a lot of these empty spaces right here. So if you just double click your SVG, you'll see all the different nodes that make this SVG one big SVG. And you can manually delete individual nodes to get a better shape. So if you zoom in on some of the fur on Powelcat's back, you can just start deleting some of the shading that was in the original image. This might be a little bit confusing, so let me just show you what this looks like in Inkscape. So this is the Powelcat that I was showing you earlier. At the top is the PNG. So if you zoom in, you can see that it's super blurry once you zoom in. But this down here is the SVG. We want the SVG to look something like this in the end. So the way we're going to do that is we're going to zoom in and we're going to take a look at some open shapes, double click, and delete any open shapes that exist within the diagram itself. You're just going to do this repeatedly until you're left with a solid black fill on the inside. And that's when you know you're done. You've gotten a shape that's going to be strong enough to actually be printed by a 3D printer. All right, let me continue the slideshow. So you're going to repeat that process over and over again until you get a shape that will work well for 3D printing. So once all the white space is deleted, you're going to see something that you like. Something else that I did for the STL I showed you at the beginning was do the same process all over again for the Powell text that I showed you in the original image. And then I used the color filter instead, and I just deleted everything except for the text in the paw that I didn't like. And I also manually enlarged the claws that Powell Cat had just a little bit because I wanted those to be stronger when I actually 3D printed them. I highly recommend you take a look at the colors filter under an Inkscape to actually do this process yourself. This is probably one of the most powerful features I've seen in Inkscape. You can also use this for embroidery. So if you wanted to make like a fabric patch, you would have to use this feature within Inkscape itself. So I highly recommend becoming more familiar with that. So now that we have our SVG, as you can see on the bottom right, this is the final SVG that we want to get 3D printed. What we're going to do is we're going to convert this SVG to an STL. So we're going to use another website called Tinkercad. Tinkercad is that 3D design software I was telling you about earlier. You're going to import your Powelcat SVG or any SVG into Tinkercad as a 3D shape. And then once you import your 2D shape as a 3D shape into Tinkercad, Tinkercad is going to be like, hey, this 2D shape needs some height. What is the height I should give this 3D shape? And then you can use the slider in the shape window to just give your object some height. And once you've given your object some height, you can just export it as an STL. So what we've done here might not sound very impressive, but it's pretty powerful. We've taken a 2D shape that we were able to design however we wanted, and then just export it as an STL without using any heavyweight software, without using any paid software along the entire way. This is something that you can use for creating any design in the future, just from a 2D shape to a 3D shape. Now, finally, that we've done all the hard parts of getting our 2D image into a series of 3D shapes, we can finally start doing our design in Prusa Slicer. Now, some extra components that I used for this particular project was a keychain STL that I downloaded from an open website called Thingiverse. Some guy named Red Jackal created a keychain of a cat's paw. So I'm using that as like the background of my plaque for Powelcat. And additionally, I repeated that same process I showed you earlier for the cat for the actual Powell text, as you can see on the right here. I'm gonna be using these three components to actually create the Powelcat commemorative plaque. So what we're gonna be doing is we just place all of our STLs on the bed in Prusa Slicer. We import them all as one shape. And then from there, we can actually do all of our editing. So let me show you what this process looks like, because explaining Prusa Slicer keystrokes without showing them is a little bit of a difficult task. So what I have here is I have the background. I have my cat keychain. I have this statue of Powelcat, and I also have the text of Powelcat right here. What I want to do is I want to get from here to something like this. I want to make sure that Powcat actually fits within the keychain. And I want to have the Powell text located around the paw the same way that was in our PNG earlier. So how am I going to do that? So what you're going to do is first, you're going to try to superimpose this cat over the background paw. And unfortunately, you can see that it's too big. So what we're going to do is we're going to remove the bottom part of Powcat as I'll show you right now. So you're going to place it on this bottom face right here, and you're just going to slice Powcat in half. I know it's probably not something you want to do, but unfortunately, what we have to do is this is necessary if you want him to actually fit on the plaque itself. So I'm going to drag this window right here, and I'm going to perform the cut, and I want to make sure that I keep both of these objects so I can use them for later. And I'm just going to delete this other object right here because we no longer need it. So let me make sure that Powcat now fits on here. Let me place him on his face. Let me drag him back onto the paw. And he more or less fits on here. We might need to cut him. We might need to cut him down just a little bit more. We might need to make the paw a little bit bigger later. But now at least he's fitting onto the shape that we want as our background. So let's now try putting all these components together. As you can see, we want to make sure that this shape right here is our background. Unfortunately, this is actually has a higher Z height than our Powcat object. So the way we're going to fix that is we're going to select our Powcat object, go to the object manipulation window in Prusa Slicer, unlock our Powcat object so that we can distort its shape in any of the dimensions however we want, and just make sure that the Z height of this Powcat, which is currently 0.3 inches, is higher than the keychain. So you can see that the keychain is 0.47 inches. Let's just make Powcat 0.55 inches tall. So now if I drag Powcat over here, he's actually going to be showing above the paw, which is exactly what we want. So let's do that. We can see Powcat is now showing above our keychain. This is exactly what we want. This is perfect. So let's see what we can do with our text. So our text currently, we want to be taller than all of our objects combined. So let's make it a little bit bigger. We're going to do that same process we just did for Powcat for this text shape right here. We're just going to make it like 0.7 inches. Awesome. So we'll make this 0.7 inches. We'll try to line it up, but unfortunately, this doesn't look super good right now. We need to keep changing the objects just a little bit more. It seems like the background's a little small, so let me just scale up everything in the background a little bit. So let's make it, I don't know, maybe 650%. That will be the current size of the background. And this looks pretty good so far. The cat is still taller than the background, so this is okay. And then the Powell is still now circling this. I think we have to make this a little bit bigger. So let me make this 110%. Oh shoot, I need to rescale this. Awesome. So this already looks a lot better. If you can see, we have our three components, which are the Powell text, the Powell cat, and the Powell background all together. So now the way we're going to see our different colors is just by slicing this shape. And then we're going to manually tell the sliced G code to add separate colors depending on the individual heights. But before I do that, let me really quickly change this to 0.58 inches. I think this just might not be tall enough, so I'm going to make it a little bit taller. Awesome. This should hopefully be a little bit better. A large part of this process is guess and check because we're not using any complicated software. So a lot of it is just finessing this with your eyes. It's a lot more artistry, I guess. So we're currently converting the different STLs we have into a G code. And what we're going to try to do is we're going to try to give each of these heights a different color. So what I'm going to do is I'm first selecting this. So I've added a color change for the cat and for the text. And as you can see, just by adding a color change for the text, I can now print the text in a completely different color than the cat. And by adding a color change for the cat prior to the paw in the background, we're gonna have a color change for that as well. Now, something that I want to add is I want to make sure that the paw isn't all just one color. So I'm just going to go down through my slice G code and I'm going to add a separate color for the background behind the paw. So I've done that just now. And let's take a look and see what it looks like when we put all of our shapes together. As you can see, now we've taken a bunch of 2D shapes, converted them to STLs, put them together into one object to create a commemorative plaque for Powellcat. Now you might be thinking, well, this is great, but like I want to make sure that I can give this to my friends. I don't want to have to make sure that my friends have to go through and design all these, do this entire design process all over again. So what you're going to do is you're just going to select the three different shapes that we have and you're going to merge them because Prusa Slicer gives the ability to merge different STLs together for you to create your own STL because if you want to design it within Prusa Slicer. So now that we've merged our Powellcat object, we can just export it as a separate STL. So this is a brand new 3D file that you're creating for someone else to use. And as you can see, if you ever wanted to just import this object again into a new window of Prusa Slicer, you could just do that. Let me show you what that looks like. So this is the merge Powellcat STL I just created. I originally created this plaque a few months ago, over a year ago for Pi Day. And as you can see, we have our entire keychain that we just created, um, just available for anyone to use. And all they have to do to add the color change in is to just slice it up, add a color change for the text, add a color change for the paw, and then finally add a color change for the background. And then they're all set. Anyone can take your design and convert it to a multicolor 3D print, which is super, super powerful. Now, the examples that I've showed you for this video are pretty basic, but you can use it for some pretty cool things further on. So as you can see here, I use this exact same process that I did for the Powellcat keychain that you can see in the middle. Sorry, commemorative plaque that you can see in the middle. I did that exact same process for the steering wheel of a go-kart. Our go-kart was for an Engineering 96 class, and it was Spider-Man themed. And we thought our car didn't have enough Spider-Man flair to it. So what did we do? We made the entire steering wheel for the go-kart Spider-Man theme. So you can see this was designed the exact same way that I just showed you. I didn't use any fancy design software. I didn't use anything that would cost me any money. I just imported shapes from Thingiverse and I designed the entire object that you're seeing right here within Prusa Slicer itself. And I think I did a brief amount of this in Inkscape, but almost all of this was done in Prusa Slicer. So Prusa Slicer is a really powerful design tool and it's entirely free. Something else that I've also done is I've used this exact process to make like graduation gifts for my friends. I took like a little the Prusa Slicer octopus. I sliced it up and I put a little graduation hat on it with class of 2024 or 2023 at UCLA on the graduation cap. So you can use this entire design flow that I showed you to make any multicolored 3D print, even if you have zero design experience whatsoever. I'm a computer science student. I never took these fancy CAD classes. I never took the time to learn the fancy CAD uh, flows, but I'm just showing you the design flow that I've done to make really cool 3D prints for me. And that brings me to the end of this presentation. I really want to thank everyone for taking the time to listen to this. It was really fun making this video. And once again, thank you all for watching. Go Bruins. Thank you so much. Bye.